Hello and welcome. That's not what I wanted. So my recording trigger actually also triggers some functionality within Visual Studio. So welcome to iPio's programming channel. There you are. So today I want to start off with the two most important things about programming. The first thing is coffee. This is very important, and it can't be emphasized enough. The thing about programming is that whoever puts in the most hours wins. You can win programming, that's totally a thing. And you need to sit down and put in the hours. And to do that, you need to stay awake. You can't be sleepy, you can't lose focus. Coffee is your friend. Just get a really thorough coffee addiction. That helps a ton. And the second most important thing is RTFM, which stands for Read the Fucking Manual. There is documentation and that's actually important. And so good documentation is just available. That's basically it. And it's usually correct. That's also very important that it is correct. To have something be correct, it needs to play a role in the actual execution of things. This is getting needlessly complicated. But if you think about, you write something and then you write a piece of code and you write documentation for it, and then you change the piece of code, you have to adapt the documentation as well. Now this step of making the documentation, you cannot do that way. You can't write your documentation that way. So you need some other mechanism of writing the documentation. But we'll get to that later. This is the C# documentation. And I think, is it Control to follow the link? I wanted to open it inside of Visual Studio though, because that's totally a thing that you can do. Open URL. No, it opens it on the other screen. That's fine. Let me quickly check if there's anything suspicious on here. You know what? Let's actually, I really want to open it inside of Visual Studio. I know this works somehow. Okay, so I'll just check out the documentation over here. This is the C# documentation. You can open it and read along. And I'm trying to find something programming guide. That sounds good. Statements. So they start with statements, expressions, and operators. Wouldn't you start with variables though? Expression bodied members. The expression body is way too complicated. Yeah, let's filter by variable. Like, I want to see all the variables. You know what? I didn't want to miss anything, so I wanted to look it up. But basically, there's a number. It's integer. You can have an integer number. What an integer is, it's a whole number that can be 0 and is optionally negative. If you need to guarantee that it's not negative, there is the sign plus or minus it's a signed number. So if you want it to be not signed, you go unsigned. Unsigned. Do I need to write int? Oh no, I miswrote unsigned. You're kidding me. Is it uint? Yeah, it's uint. Okay. So unsigned is from C++. I'm confusing programming languages all the time. And you actually never want to write unsigned. I'm not entirely sure about C#, but there are typically guarantees attached to unsigned that are not attached to integer. So you basically only want to use integer because it has less guarantees attached to it, which means everything you do with it is faster because you don't get as much guarantees. We get into software testing later because the fewer guarantees you have, the more important it is that you test this. So A equals 5, B equals 7. A can be -5, B cannot be -7 because it's unsigned, it doesn't have a minus. But both can be 0. See, let me demonstrate. Then there are things that have a dot in them, like numbers like float. Can have a dot, 5.7. So that's kind of the decimal dot. I'm not allowed to write it like that because now I did not use a float. Floats end in an F. That's very important for the compiler because I can write 5.7 and actually mean to write a double. And it can't be B because I used that one. So now it's D. So this now is a double. Why does it look like that? Okay, let me just save it and then all the helpers go away. So that's a double. There's another one, decimal, which can also be 5.7. So do I have to write D or something? How do I write decimal? I never use decimal. It's an M suffix. All right. So the things about the difference between the three is precision. You basically, unless you have any special reason not to, you use a double. The thing about the number that they can span, kind of if you go into the really precise bits, they split up a bit, and you can't actually reach all of the precise numbers. So that's why you have different types for them. Decimal, for example, has a different way of structuring its binary bits so that you get different behavior in those parts. Not too important. Just integer, unsigned integer, float, those are really helpful ones. Float, one reason to use that would be to save memory when you need to have smaller numbers, because double is double the size of a float, I think. If you're dealing with really big numbers, you also get a thing called long. I think F is unused. I should go down here. Long F equals 6. And you can see I can write 6. Can I write 6.7? I can't, because long is an integer as well. So that's why I started writing it up to the integer. Let's get it up here. If you need like constants and you're wondering how big something is, you can go integer dot max value, because there's a bit more to it, and you can already see in the tooltip, like, that's a big one. Let's go long dot max value. See, even a bigger one. So there's really no reason. If you need to do reproducible math, you want to go integer numbers, right? Because there is I think it's IEEE is the guys who defined what a float is, and there's a very precise definition of what a float is. What's missing though, it is what happens when you multiply floats, and it's undefined, so that the processor can do stuff like it wants to, but it makes the whole floaty thing faster, but it makes it so that you might get different results on different processes. It's actually a good question if that's true for C# as well. It's definitely true for C++. So if you want to do precise math, just go integers. Like if you want to deal in pennies, just make pennies your integer value, and then you can get up to other currency based on that. Just, yeah. And that's about it for variables. There's one more. So these are all mutual, which means they cannot be changed. How can I demonstrate that? Let me go for an experiment for you. Okay, I'll have an integer a, and let's say it's 6. I'm going to go write line console dot write line a. Okay. So now you're wondering, what do you mean they can't be changed? See, if I go a equals 8 and I write that out, what do you expect to happen? Well, my expectation would be it writes 6 and it writes 8. That's actually what happens. Now, which makes it even more a mystery why I'm saying you cannot change these values, right? Because clearly you just changed them. Let me go into one more thing. If you make a sub function, so you can see that this main function is it has like the signature where it says private static void main and then args, and it has the some parts. Every part is interesting here. It's actually super relevant. Let's just write our own. In C# it doesn't matter if you add it above or below. That's totally fine. C# can handle that. Private, yeah, let's go. It doesn't matter. We don't need to know if it's private or not. If you want to call it from a static method, it has to be static itself. Otherwise, we have to create a new object first. We'll come into objects like probably next video, because this one has been going on a lot. Static void, and let's go my super sub function, and then go integer x, because x is cool, and then we go write line x. So you can see that this does nothing. Why is it underlining everything? Let's go private. I think it's just complaining that this accessor is missing. What are you complaining about? Remove the unsafe, unused. Okay, yeah, let's just use it then. My super function a. Okay, now I'm just replacing these, right? So nothing happens. This is just going to go like the console write line is just also a function that someone else has written, to the point where if I write, you can see the console is written just like this program class. And that's actually because it's static within the console. So I can also write program dot, because this one is static within the program. Just go program dot, see? And it has the same coloring. Now it's graying it out a little bit because my compiler is saying you're being an idiot. You're inside the program class. Why do you address it that way? So yeah, but I want to demonstrate. That's why I'm addressing. Stop complaining, computer. Program. Yeah, so you can see this is the same thing. And so someone else has written that write line, and through the reference we imported that. I think it's actually in system. I could actually go, because system, that's kind of the namespace. So here I could go, I think it's a system.console, right? Yeah, see? So this one is in system.console. That's just how namespace is. Namespace is like your address, where you live. So this one lives, console lives in system. And it's graying it out again because it's saying you're being an idiot. I'm not an idiot. So now I need it because it eliminated the using statements. See? And he stopped complaining. And he's also complaining. No, don't overwrite anything. Suppress. Yeah. Okay. I'm doing advanced stuff, which I shouldn't. Advanced. Okay. My point here is that this one is calling now the write line and it prints it, right? 6 and 8. Now how do I do this? I can go x equals 20 and then output it again, right? So now what happens? X, oh, actually, I need to print this again for you to see that. And let's not go x20 yet. Okay, so what happens? I'm going in there with 6 and print it twice, 6, 6. I'm going in there again, print it twice, 6, 6. Going in there again, print it twice, 8, 8, and 8, 8. Okay, now change it to 20 in here. What happens? I'm going in there with 6. Wow, it's gone. I'm going in there with 6 and print it in the first statement. Then I change x to 20, and now it's 20, and I print it. But you see, I jump back and then I go into it again, and it is 6 again. So this value didn't change, and that is what I meant. It cannot be changed. It is mutual. It's not entirely true. It's copied, basically. It's copying the value because this is a value type. It's actually in C#, this is called value type. The behavior here is value type. It makes a copy. So it's copying this thing. And then when I modify kind of the content, I'm modifying the copy, and the copy gets thrown away. There's another variable, and this is why I was going into it. There's the string type. String in C# behaves exactly that way. But it's actually, they had to hack the whole system to make that happen, because that's not normal behavior for string. If you're used to C++, for example, Meister and console. Oh, now he doesn't know console anymore. Okay, using system. Now here let me give you the shortcut. Control dot gives you the hotfix menu. If there's anything broken, you can try control dot and see what he's offering. And using system, it's usually faster to do it that way, even if you know exactly what the problem is. Just using these mechanisms, it's faster to type. Write line and then go S. Okay, now this one writes string. String behaves the same way, and you can kind of see everything that's written small and blue is kind of a value type. That's a good heuristic. String can be written that way too. This doesn't change the behavior. This is now written like a class, like this program class up here. These are classes. String can be written like a class, but the behavior stays the same. The behavior is like that, like a value type. Classes behave differently, and we go into classes next. Thank you so much for watching. See you all next time. Bye. Make sure you click over here so I don't trigger anything when I stop the recording.